11a. It says a 0.5 microfarad capacitor and 30 ohms resistor, a 0.05 inductor are connected in series across a voltage source of EMF 50 voltage root mean square, 100 over pi has. Calculate I inductive reactance, II capacitive reactance, and III impedance. Now, before we go to the calculation, let's make a diagram of this form. So we have a resistor, and this resistor we have it to be 30 ohms. It is connected to an inductor. This inductor is 0.05 inductant, okay? And then we also have a capacitor of capacitance 0.5 microfarad, all right? And then it is connected across a voltage of 50 volts root mean square, and also 100 over 5 pi frequency. So now this is the sketch we have, representation of this. Now to find the inductive reactance represented as X inductive on this form is equals 2 pi FL. Alright, whereby F is equals 100 over pi, and then L, which is inductance, is equals 0.05. All right, and then 2 pi is just there. Now this is furthermore equals 2 pi multiplied by F, which is 100 over pi. All right, and then multiplied by the inductance, which is 0.05. Remember that I didn't change this pi over here to maybe 22/7 or the other way around in decimal, because I would like to use it and cancel this pi that I have over here. So that 20 multiplied by 100, I have 200 multiplied by 0.05. When you use 200 and multiply by 0.05, you'll be having 10. And this is how to have as our what? Inductive reactant. So that's the answer for the first one. The second, we have capacitive reactance. So capacitive reactance, as something like this, is given by 1 over 2 pi Fc. And then I know what my F is, I also know what my C is, so that capacitive reactance equals 1 over. I won't like to change this pi because I have the frequency to be 100 multiplied by 100 over pi, all right, and multiplied by the capacity, which is 0.5. So therefore, I'm going to have the capacitive reactance equals this. We cancel this, leaving with 1 all over 2 multiplied by this is 200 multiplied by 0.5. 200 multiplied by 0.5 means the half of 200, which is going to be 1 over 50. And then 1 over 50 should give us 0.02 measured in ohm, just like the inductive reactance, 0.02 ohms. The last one, we get the impedance. The impedance represented as Z is equal to the R square plus bracket inductive reactance minus capacitive reactance all to square, and we also have square here. So removing this square, I'm going to root the both sides. So inductive reactance equals this, and then inductive reactance equals the root of what is R, which is the resistor 30 square, plus the bracket, what is did I have as inductance? I have it as 10 minus 0.02 all to square. So that I'm going to have inductive reactance equals 30 raised to power 2 is 3 raised to power 2 is going to give us 99200, and this is going to plus the bracket 10 minus 0.02 should be giving us 10 minus 0.02. We are going to have 9.98, and then all to square. So we square that 9.98 square. We are going to have inductive reactance equals 900, the root of 900 plus 99.6004. All right, so plus 900, we're going to have the inductive reactance equals the root of 999.6004. So if you work that out, the root of 99.6004, we are going to have it to be 31.6 to one decimal place, and this is what we have as impedance, also measured in ohms. Question 11bi, state Faraday's law of electromagnetic inductor. This law states that a charging field within a rope induces an electromotive force in the rope, that is EMF. 11ii, list the factors upon which the magnitude of an induced EMF depends. It depends, number one, the rate of charge of the magnetic fields. Number two, the type of coil material. The type of material the coil is being built with. Also, it depends on the area around the coil. It also depends on the number of turns of the coil. Question CI, define gravitational potential. Gravitational potential V in a magnetic field is the work done per unit mass in bringing a small charge from infinity to that particular point. Gravitational potential V is also known as the Gm all over the distance from infinity to that point. Why this is the gravitational constant? The final question, state the Newton's law of universal gravitation. This law states that the force of attraction between two bodies, M and M, is inversely proportional to the square of their distance, R, and directly proportional to the product of their masses. So we can represent it mathematically as a force of attraction is inversely proportional to the square of their distance, which is represented by R. Also, that same force is directly proportional to the product of their masses, which is M and what? M. Because their masses are not the same, so that we now have that F is inversely proportional to 1 over root square multiply by M multiply by M. So that we are going to have that F, removing this, we are going to put gravitational constant, and we're having M. We make this M to be bigger and this one to be small. We have root square. This is the gravitational force. Why this one is gravitational constant. Alright, that is it for this video. Don't forget to give this video a thumbs up if you like it, and if you're new, don't forget to subscribe. In my next video, I'm going to be treating more questions on this 5th December 2025 Physics WAEC GCE. Thank you.